In this video, we're going to take a look at statistics. We're going to look at some of your basic mean, median, mode, range. Those are statistics you've done in the past. And then we're going to get into variance and standard deviation. Statistics just include a numerical value used to summarize and compare data. Now, statistics are used really, really well by newspapers, by politicians, to make data look the way it's helpful for them. So the more you know about statistics, hopefully the better it is for you to be able to read a graph or to be able to understand some kind of statistical presentation that someone gives you. Because they can use a certain statistic to make things look better, which is why we have numerous ways to take a look at these. We'll be looking at two different types. The first one we're going to focus on is called the measure of central tendency. Those are the ones that you're familiar with. And I'll define these in just a moment. And then the second one we're going to look at is measure of dispersion. Central tendency, you're going to recognize more. Dispersion is definitely going to be something new for you. So, measure of central tendency. The measure of central tendency is a number to represent the center or middle of a set of data. So when we're looking at what happens in that middle area, that's why it's called central tendency, center. Examples of these would be your mean, average, median, middle number, and mode, most often number. So those are the three that you should be familiar with. Those are all measures of central tendency, looking more so in the center of your data. So your mean, which we also call our average, will be denoted with X, and then there's this bar above the top of it. We call it X bar. And the mean is just adding up each of your individual values all the way up through that last nth value and dividing it by n, the number of values that are there. So that's going to find your average for you. Your median is just the middle number in ordered data. Important to note, it has to be in order. So if you are going to calculate a median, you're going to have to list your numbers in order. Sometimes it's helpful anyways, but sometimes you might have a ton of numbers, and finding the median is not a very quick process. And then mode is the most frequent number. To find your mode, it might be helpful to put them in order. You don't have to, but it's probably going to be the quickest way to see it. So you find out which number occurs most often. Now, please note that there might be more than one. There might be only one, and there might be none. Usually, if we're going to look at data, if there's two modes, no modes, one mode, or two modes, it's a decent number to look at. But if there are multiple modes, if there's multiple numbers that occur 3 times, the mode is probably not a good statistic to take a look at. Then we have measure of dispersion. Measure of dispersion is just a statistic that tells how spread out our data values are. And an example of this would be range from your max to your min. And then these two new ones, which are variance and standard deviation. Range is just telling us how far apart your max and min are. So the range is just your max minus your min. Okay, that's going to give you the range of the data. Don't get that confused with domain and range. Range in statistics is just your max minus your min. Standard deviation is, or it describes, the typical difference, between a data point and the mean. The bigger the standard deviation, the farther away those data points are from the mean. So if you think about a test, if the average was an 85 and most people scored between an 83 and an 88, your standard deviation is going to be very, very small. That difference is not very big. However, if your mean is a 70% and I have ranges from the 30s all the way up through the 100s, that's going to be a little bit different. It's going to be a little bit more spread out. So then that standard deviation number is going to get a little bit bigger. In order to calculate the standard deviation, we'll be calculating the variance. To calculate the variance, first off, its notation looks like the following. That's a lowercase sigma. It's a circle with a top on it, squared. Sigma meaning sum. Because what I'm going to do is I'm going to take my data point and subtract the mean and then square it. So that gives me the difference between one data point and the mean. Because remember, standard deviation talks about all of them. And then I'm going to add my next data point, so x sub 2, minus the mean and square it. I'm going to do that for all of my data points until my last one, x sub n, minus the mean, and then I'm going to square it. And then I divide it by the number of items that we have, so we can find that average distance. Now, I square each of these values because some of them are going to be below the mean, so they're going to be negative. Some of them are going to be above the mean, so they're going to be positive. So if I just added all those up, I'm going to end up getting right around 0. Maybe some round off error along the way. So that's part of the reason for the squaring, is so I can find that distance, okay, between each of them, squaring them. That's my variance. However, I have all of that stuff is squared. Purpose for that, again, making them all positive. So standard deviation, its notation is just sigma. And it is exactly what's above, but it's the square root of it. So I take all those differences, I square each individual one, I add them all together, I divide by n, and lastly I square root to figure out what that average distance is. So what we are going to do is we are going to calculate the standard deviation for this set of data. Now, you're going to practice mean, median, mode, and range on your own. I'm not going to go through those, but we're going to go through the new one, which is the standard deviation. Now, if you see the table, I have my specific x values on the left-hand side. In the middle, x minus x bar is helping me calculate my variance. And then the next one, x minus x bar squared, completely helps me do that. I'm going to have to add them all up and I have to divide it by n, and then to find my standard deviation, I just square root it. So the majority of the work is actually found doing the variance, and then I'll square root it to find the standard deviation. So before you do anything, you're going to have to calculate the mean. So I guess you'll have a little bit of practice with calculating the mean. So to calculate the mean, I'm going to add up all my x values and divide it by 7. So 12 plus 15 plus 17 plus 13 plus 9 plus 16 plus 21, and divide that by 7, and this gives me my mean. Now, keep these values stored in your calculator so you can get this as exact as possible. So x bar, I'm approximating this right now, is 14.714. Okay. That number needs to be stored in your calculator, so it's exact. So now what I'm going to do is I'm going to take each of my x values and subtract x bar. So I'm going to take 12 and subtract 14.714. Okay, and that's going to go in that second column, and then I'm going to square it to go into this third column. Now maybe you want to do all of these steps at one time. It's up to you. This is just a way to organize it. So when I subtract the 2, I get negative 2.714. Now I'm going to square that right away, so I don't have to do it again, which is 7.367. I am storing that in B. I stored x bar in A in my calculator. Remember, STO alpha A, STO alpha B. So that way when I come back and I add them all up, I can just hit all my alphas. So now I have my B values stored. So now I do 15. So it's 15 minus 14.714. And then square that value, and I'm going to make that C. So do that for all of these values. So now I found all my distances, or differences, squared. So now I'm going to take all those and add them up. Because variance says I add up all my differences. And when I do that, I'm going to hit alpha B plus alpha C plus alpha D plus. Instead of having to type in all of this stuff, I just have to do alphas at each of these. Less likely to make a mistake, and you'll have a much better answer. So when you add all those up, so do that now, please. You get 89.429. So what I just did is I did my variance, which is sigma squared. I added them all up, and now I have to divide it by n, and we had 7 items in here. So the variance squared is 12.776. So now, my standard deviation, I square root it, gives me 3.574. So what this tells me is about how far away my data points are from my mean. My mean was 14.714. So when I look at all of these, 12, 15, 17, etc., when all is said and done, they're about 3.574 units away from that mean. Okay, again, that's what it is on average. So we'll be able to look at these types of situations. The last piece of data that I want to look at is an outlier, because sometimes one data point might throw everything off. So for instance, maybe I had one data point that was 1 million. Well, that doesn't fit any of this. That's going to be an extreme value. So we are going to look lastly at outliers. An outlier is just a value that is substantially different from the rest of the data. They can be misleading, because they greatly affect measures of central tendency. And they're also going to affect then your standard deviation, because your standard deviation is going to be based on the mean. I mean, if you think about if we were to do a poll and we were to look at the average number of siblings somebody has, and we polled everybody, and the majority of folks had 1 or 2 siblings, and one person had 19 siblings, that's going to skew your data very, very quickly. Okay, especially if we don't have a large number of people. Maybe we only have a class of 15. Well, that adds 1 sibling to every single person. So there's an outlier effect. Now, that outlier is still part of the data. If we were looking at our class, we would find that average with that person in there. We can't just throw them out. However, sometimes we will also do a calculation excluding that situation. That way we can see a little bit closer of an effect of overall. However, that one person could throw off your data quite a bit. When you're organizing your data, I had talked about when you are finding your median, you have to have your information ordered. And sometimes that's kind of tough to do. You might want to draw a dot plot to help yourself organize it. And just a quick review what a dot plot is. When you do a dot plot, you're going to look at putting dots where we have information. So for instance, let's say we were measuring the length of feet. And one person had a 23-inch foot, a centimeter foot, excuse me. One person had a 20 centimeter foot. Then we had 25, 23, 21, and 20. So we just checked out 6 different people. So to help organize this data, you may wish to do a dot plot. For a dot plot, going up the left-hand side is frequency. So 1, 2, 3, etc., more if I need to. And then across the horizontal is what we're looking at. So I'm going to look at my lowest length is 20. And then we'll look at 21, and then 22, 23, 24, 25. And if I had to keep going, I would. I'd continue to count out this way. This is the length of a foot in centimeters. And then for the dot plot part of it, I just put a dot where it falls. So I have one person that has a 23 centimeter foot. And then one person has a 20 centimeter foot. And one person has a 25 centimeter foot. And one person has a 23. So now I get another dot, so that goes up to 2. 2 people have a 23 centimeter foot. And then one person has a 21 centimeter foot, and then one person has a 22 centimeter foot, or 20 centimeter foot. So this helps me organize my data so I can find my median point a little bit easier. I can also find my mode. My mode is 20 and 23. 2 of them have 2 dots. Okay. If I count in, my median falls between 21 and 23 because I have 6 data points. Therefore, I average them. My mean is 22. My median, excuse me, is 22. Median. To find my mean, I'd add them all up. 23 plus 20 plus 25 plus 23 plus 21 plus 20 divided by 6, and that'll give me my mean. So just kind of a quick refresher on each of the basic centers of spread, central tendencies, excuse me. And then this is a dot plot, just a way to organize your data. Technically, though, you do have to have a label here, and then this left-hand side is just our frequency, so we can just count.